All right, today let's work on home connection, page 41 and 42, titled Finding Equivalent Expressions. Name and number up at the top. Number 1, match each fraction expression on the top with an equivalent decimal expression on the bottom. So here are all my fractions. Here are all my decimals. So I need to think which of these fractions matches up with what it would look like as a decimal. So when I look at these problems, I'm going to say this fraction out loud to myself. 4/10. 4/10. I'm going to think about what that would look like, maybe with money. 4/10 I know would be 40 cents. 20/100. What would that look like with money? That'd be 20 cents. So here's how I write it. So now I'm going to find 40 cents plus 20 cents. No. This one looks really close. The only thing we need to do is add a 0 in the end and it will match. And with decimals, you can do that. So that matches up there. Next one, 60/100 would be like 60 cents. Minus 1/10 would be like having 10 cents. So it would look like 60 cents minus 10 cents. Is there any that match up? This one right here, we just have to attach a 0 and it would be the same thing. Okay? I want you to finish number 1 on your own. Just pause the video to finish it, and when you're done, you can restart the video. Number 2 says, evaluate each expression. Represent your answer as both a fraction and a decimal. Okay, so I can solve this the way that it is right now. 60 cents minus 25 cents would be 60 minus 25 is 35 cents. Now, how would I show that as a decimal? How do I show 35 cents, or as a fraction, I'm sorry. How do I show 35 cents as a fraction? Yeah, it'd be like having 35/100. Okay. Over here, 70 cents minus 55 cents. How much money would I have left? 15 cents. How do I show that as a fraction? 15/100. Last one on the top. 0.2 is like having, and if I attach a 0, it's like having 20 cents plus 5 cents. 20 cents plus 5 cents is 25 cents. How could I show that as a fraction? Yeah, obviously I could do 25/100, or the most common one, 1/4 is the same as 1/4. Okay, now we're going to switch our thinking in the bottom row. We're going to solve with fractions, and we're going to figure out how we would write it with money. Okay, so 40/100. Let's think about what that would be for money. That would be 40 cents. Minus 1/10. What would that be for money? Be like having 10 cents. If I subtract 40 cents minus 10 cents, I get 30 cents. My answer, I've shown it as a decimal. Now I have to show it as a fraction. How do I show 30 cents as a fraction? Could either be 3/10, 3 dimes, or 30 pennies, which would be 30/100. Either one. Next one, let's do the same thing. Let's talk about money first. 4/10 is how much money? 40 cents plus 60/100 is how much money? 60 cents. If I add those together, 40 cents plus 60 cents, how much do I get? $1. How would I show that as a fraction? I could do 100/100. I could do 10/10. All of those would work. 1/1 would be fine. Okay. And letter F, 9/10 plus 30/100. Let's show it with money first. 9/10 is the same as 90 cents. 30/100 is the same as 30 cents. 90 cents plus 30 cents is 120 cents. Okay, how do I show that as a fraction? I have $1. And how do I show 20 cents as a fraction? I could do 20/100, or I could do $1.02, Or I could do $1.01. Any of those would work. All right, let's go into number 3. Students at Jonah's school can walk or run laps at recess. At the end of each month, the class that has covered the most distance is recognized by the parent group. So letter A says Jonah and Haley walked 4 1/3 laps around the track yesterday and 3 1/2 laps today. How many laps did they walk together? That's the question. In the last 2 days, and I have to show my work. So I'm adding 4 1/3 plus 3 1/2. What do I need to do before I can start adding? Yeah, I have to make common denominators. So I'm going to make 1/3 into a fraction that has the common denominator that we're going to use for 1/2. What's a number that works both with a 3 and a 2? Should we use a 6? All right, let's rewrite them as fractions that use a 6 as my denominator. 3 times what gets me to 6? 2. So I have to take the top times 2. 1 times 2 is 2. 1/2. How many 6s is that? I don't even have to think too hard on this one. 1/2 is the same as 3/6. So now let's rewrite this problem using our new fractions. So I'm going to keep the 4. Sometimes 5th graders tend to forget that they have to keep that whole number. Keep the 4. Rewrite 1/3 as 2/6 plus keep that 3. Don't forget that step. And 1/2 is 3/6. Now I can go ahead and add. Let's add our whole numbers first. 4 plus 3 is 7. 2/6 plus 3/6 is 5/6. That's how many laps. All right. Letter B says Jonah ran 1 3/4 laps on Monday, 2 3/10 laps on Tuesday, 6 1/5 laps on Wednesday. How much farther did he run on Wednesday than the other 2 days combined? Show your work. So I need to combine the other 2 days right here. So first I have to add 1 3/4 plus 2 3/10 because I need to combine those, which means all together. So let's come up with a common denominator that we can use for 3/4 and for 3/10. What works with both a 4 and a 10? What could we use? How about a 20? 4 times what gets me to 20? 5, so I have to take the top times 5. 3 times 5 is 15. Okay, next one. 10 times what gets me to 20? 2, so I have to take the top times 2. 3 times 2 is 6. Let's rewrite this problem with our new equation. So I have to keep the whole numbers. Don't forget that. Instead of 3/4, I'm going to write 15/20. Keep my 2. Instead of 3/10, I'm going to write 6/20. Now I can add. They have the same denominator. Whole numbers first. 1 plus 2 is 3. 15/20 plus 6/20 is 21/20. Now, can I change 21/20? Yes, I have another whole. So 21/20 equals 1 whole, and how many left over? 1/20 left over, but I still have to add it to this 3. So 3 plus 1 is 4, and I still have that 1/20. We're not done though. That's how much he ran on Monday and Tuesday. They want to know how much farther did he run on Wednesday. So we need to take 6 1/5 minus the combined total that we figured out before, 4 1/20. Okay. Can I just go ahead and subtract it? No, because I don't have a common denominator, so we're going to fix that. Let's set up our ratio tables. What's a number that works both with a 5 and a 20? Let's keep that 20. It saves us some work. That means I only have to change this fraction. I can keep this one. 5 times what gets me to 20? 4, so I have to take the top times 4. 1 times 4 is 4. Now let's rewrite this again. 6 and 1/5, keep your 6. Instead of 1/5, what can we write? 4/20 minus, and we get to keep this problem, this fraction the same. Okay, let's start with our whole numbers. 6 minus 4 is 2. 4/20 minus 1/20 is 3/20 of a lap more on Wednesday. Okay? All right, let's flip to the back side. There's Jonah. He's back again. Jonah and Haley made brownies to bring as a class treat. My favorite. Some were plain and some had sprinkles. The class ate 3/4 of one pan and 1/6 of another pan of the plain brownies. They were hungry. They ate 5/6 of one pan and 1/10 of another pan of brownies with sprinkles. They ate a lot of brownies. If the brownie pans were the same size, did the class eat more plain brownies or more brownies with sprinkles? So first we have to figure out how much they ate of each kind. Well, they ate 3/4 plus 1/6 of that first kind. 3/4 plus 1/6 of the plain kind. So we have to figure out how much that is all together. I can't just add them. I have to come up with a common denominator. So I'm going to find something that works with, and I'm going to do my work over here this time, with 3/4 and 1/6. What's a number that works both with a 4 and a 6? What could we use? We could use 24. 4 times what gets us to 24? 6. So I have to take 3 times 6, which gets me to 18. 6 times what gets me to 24? 4. So I have to take the top times 4. 1 times 4 is 4. Let's rewrite this problem now as 18 24ths plus 4 24ths equals 22 24ths. That's a big number. Do you think I can put it in its simplest form? Let's see if we can do it. What's a number that goes both into 22 and 24? Should we try 2? They're both even. If I take 22 and divide it by 2, I get 11. If I take 24 and divide it by 22, I get 12. This is in its simplest form. Okay? Now, that's how many they ate of the plain brownies. How much did they eat with the brownies with sprinkles? Well, we need to add those together. So we need 5/6 plus 1/10 now. All right, so I'm going to show my ratio table. I'm just going to write it over here. We need some common denominators. What's a number that works both with a 6 and a 10? Let's do 30. 6 times 5 gets me to 30, so I have to take the top times 5. 5 times 5 is 25. 10 times 3 gets me to 30, so I take the top times 3. 1 times 3 is 3. So let's rewrite our problem now as 25 30ths plus 3 30ths. What do I get when I add them together? I get 28 30ths, don't I? That's a big number. Can I shrink this down at all? Can I make it in simplest form? Let's cut it in half. Half of 28 is 14. Half of 30 is 15. So I'm comparing 11 12ths and 14 15ths. Okay, so I'm comparing. This was the sprinkles brownies. Both of them are almost a full pan, right? Both of them are almost a full pan, except for one piece away from a full pan. When we compare fractions, let's come up with a denominator that works for both 11 12ths and 14 15ths. What's a number that works with both of these so that we can use it to compare? Let's use 60. 12 times 5 equals 60, so I have to take the top times 5. 11 times 5 is 55. 15 times 4 gets me to 60. So I have to take the top times 4. My thinking strategy for 4s is first I'm going to double 14 to get 28, and then I'm going to double 28. 28 doubled is 56. Okay, so now I'm comparing. Remember, this is plain, this is sprinkles. Which one did they eat more of? Now I can compare. They ate more of the sprinkles. Okay, we've shown our work. It's all over here. How much more? So I have to take the biggest one minus the smallest one. 56 60ths minus 55 60ths is 1/60th of a pan. That's a doozy. That was a tough problem. Lots of steps. If you have any questions, please ask me tomorrow when you turn it in.